After confirming ignition and achieving liftoff, early assessments cautioned against collecting merely fuzzy photos. Intervened with spacecraft adjustments, NASA's Voyager 1, now over 45 years old and 24 billion kilometers away from Earth, serves as a reminder of science's humility in the vastness of space. In this exploration, we explore the mystery surrounding Voyager 1's recent anomalies. Are we on the verge of losing connection, signaling the probe's demise? Is there a possibility of extraterrestrial interference with the probe? Join us on a voyage through space to analyze odd signals and discover the true state of Voyager 1, the legendary explorer. To understand the significance of Voyager 1's problem, we must first recognize its monumental nature. Launched in 1977, the mission was anticipated to endure only 5 years but defied all expectations. Voyager 1 and Voyager 2 have exceeded expectations by relaying crucial scientific data from our solar system's outskirts for almost 4 decades. Initially tasked with investigating Jupiter and Saturn, they have succeeded beyond their original objectives. In August 2012, Voyager 1 entered interstellar space after 35 years of mission, marking a milestone in space exploration confirmed by NASA in 2013. Voyager 2 provided close-up views of Uranus and Neptune. Voyager 1, the farthest human-made spacecraft from Earth, has transformed our understanding of space by showing interactions between the solar wind and the interstellar medium, as well as the nature of the heliosphere. Voyager 1's journey has left a lasting legacy of space exploration. Scientists predict that the first contact with extraterrestrial life could occur by 2029, with messages reaching intelligent life forms as early as 2022. This contact marks a pivotal milestone in human history, sparking interest in the consequences and highlighting Voyager 1's resilience. The device's longevity is noteworthy since it can withstand harsh conditions such as radiation, severe temperatures, and the threat of micrometeorites. Voyager 1's 46-year voyage highlights human engineering and the spirit of exploration. The spacecraft's longevity can be attributed to its robust construction designed to withstand cosmic radiation, extreme hot and cold swings, as well as space rocks. The probe's longevity can be attributed to its reliable power source, nuclear batteries, sometimes called radioisotope thermoelectric generators, RTGs. They use heat from plutonium decay to generate power. The RTGs have been the core of Voyager 1's power system for nearly 4 decades, although their power production has decreased due to radioactive decay. Voyager 1 is more than simply a spaceship. It's a brainy explorer equipped with scientific tools like a Swiss Army knife. Voyager 1 has a cosmic ray subsystem, CRS, a high-gain antenna, and an imaging science subsystem comprising an infrared interferometer and spectrometer, IRIS, low-energy charged particles, LECP, a magnetometer, MAG, optical calibration for the OOC photopolarimeter subsystem, PPS, planetary radio astronomy, PRA, plasma science, PLS, and the plasma wave subsystem, PWS. RTG ultraviolet spectrometers complement these equipment, which perform vital functions. Voyager 1's close-up images have revealed details about huge planets and their moons, including Jupiter's cloud patterns, wild winds, and storms. It discovered a volcano on Jupiter's moon Io. Located at Saturn, the rings were more than just beautiful jewelry with unique twists, turns, and spokes. FKS offers a variety of ringlets, but it's more than simply aesthetics. These instruments have studied cosmic rays, charged particles, magnetic fields, and plasma waves. Meanwhile, Voyager 1 is carrying a message from Earth to the unknown: the Golden Record. The Golden Record is a unique attempt by humanity to connect with any alien beings encountered on their infinite journey. The Golden Record is a unique artifact consisting of a 12-inch gold-plated copper disc with carefully selected sounds and visuals that represent the diversity of life and culture on Earth. This CD has 116 images and a symphony of sounds that tell the tale of our species and planet. It aims to bridge the gap between civilizations separated by space. Enjoy music and spoken greetings in 55 languages from around the world, as well as natural noises like thunderclaps, birds singing, and whales making haunting noises. The committee, led by renowned astrophysicist Carl Sagan, carefully selected each element to represent a diverse range of cultures and experiences. The golden record is entrusted to Voyager 1 and its twin, Voyager 2. These Voyagers may deliver a message from Earth, which could be discovered by extraterrestrial life in the distant future. If a sophisticated extraterrestrial society discovers Voyager 1 and retrieves the golden record, it would be a historic event in interstellar communication. There are three possible outcomes. Extraterrestrial civilizations may use advanced technology to decipher the golden record, including visual and auditory information. Scientists predict that if extraterrestrial beings are capable of interstellar travel and communication, they may return a signal to Earth by 2029. Alternatively, Voyager 1 could be studied as a historical artifact without interference. They might want to respect the principle of non-interference in other civilizations' development, a concept explored in many science fiction stories. In any case, if there were ever an encounter with extraterrestrial beings, it would be a massive and potentially world-changing event for humanity. However, Voyager 1, despite its long and faithful service, has recently introduced an element of intrigue into its mission. It has begun transmitting perplexing data from the fringes of interstellar space, sending NASA engineers into a state of bewilderment. This anomaly stems from a crucial onboard system known as the Attitude Articulation and Control System, AACS. This system is responsible for measuring, reporting, and adjusting the spacecraft's position in the unforgiving expanse of space, ensuring that its antenna stays pointed toward Earth for communication and data transmission. Yet, inexplicably, the AACS returns data that contradicts the spacecraft's actual movement and orientation. It's as if Voyager 1 has become disoriented, uncertain of its location in the cosmic void. NASA assesses the scenario as both comforting and confusing. Despite erroneous data from the AACS, Voyager 1 continues to function correctly, receiving commands from mission control on Earth and collecting crucial scientific data from its far location. The spacecraft appears unaffected by the anomaly, and no onboard fault protection systems have been activated to put it in a protective safe mode. Interestingly, Voyager 1's transmission signal remains a powerful beacon in the emptiness. The high-gain antenna points to the correct planet, but the telemetry data produced by the AACS appears random or defies explanation. Suzanne Dodd, project manager for both Voyager 1 and Voyager 2, sheds light on this confusing scenario. The Voyager mission has faced unexpected challenges, including spacecraft aging beyond their intended lifespan, traversing interstellar space, and entering uncharted territory. Despite these challenges, the engineering team remains optimistic about finding a solution. In 2017, Voyager 1 faced a similar challenge when its primary thrusters began to wear out. To continue the mission, engineers had to switch to thrusters that had not been used in 37 years during the spacecraft's planetary missions. However, there is a new twist in the tale. NASA's ingenious engineers have identified the problem with Voyager 1. It turns out that the AACS was sending telemetry data to a computer that had failed a long time ago, and this corrupted the data. The project manager suspected this was the culprit and took a calculated risk by repeatedly commanding the AACS to send data to the correct computer. While the engineers are still uncertain about why the AACS malfunctioned, a malfunctioning command from another onboard computer likely triggered this anomaly. If that's the case, it suggests that an underlying problem on the spacecraft may exist elsewhere. The team remains committed to uncovering the root cause, although they believe it doesn't significantly threaten Voyager's overall health. Nonetheless, they are eager to understand Voyager 1's inner workings better. However, it's important to recognize that Voyager 1's journey through space will eventually end. In fact, time is running out for this intrepid explorer. This leads us to a pressing question. How long can NASA's Voyager continue its incredible journey? Before delving into the question of how Voyager 1 communicates with us from a distance of 24 billion kilometers, it's important to understand the factors that determine how far it can travel before losing contact. Voyager 1 relies on a well-designed radio communication system that efficiently transmits and receives radio waves through 3 Earth-based stations. When Voyager 1 communicates with Earth, it usually does so via Deep Space Network Channel 18, utilizing radio frequencies of either 2.3 GHz or 8.4 GHz. Conversely, when we send signals to Voyager, we do so at a frequency of 2.1 GHz. The sophisticated communication setup allows Voyager 1 to maintain a connection with our home planet even as it journeys into the vast unknown. However, the distance Voyager 1 has traveled means that direct communication with Earth has become increasingly challenging. To overcome this, the spacecraft is equipped with a digital tape recorder, DTR, capable of storing roughly 67 megabytes of data. This recorded data can then be sent back to Earth later when conditions for communication are more favorable. As of 2023, it takes over 22 hours for signals from Voyager 1 to reach Earth, which is a stark contrast to the roughly 15 minutes it takes for the Mars rovers to transmit data back to us. Another essential factor to consider is the weakening of Voyager 1's signal as it traverses the vast cosmic distances. The spacecraft initiates data transmission to Earth using a 20-watt signal. However, over its long journey through space, the signal progressively weakens. By the time it reaches Earth, it has become exceedingly faint. Nonetheless, the strength of the signal isn't the primary concern when communicating with objects at such colossal distances. The critical factor is having a susceptible receiver capable of detecting these faint signals. To meet this challenge, NASA relies on the Deep Space Network, a network of 3 antenna complexes strategically positioned around the Earth. Each complex boasts a substantial 70-meter antenna and multiple 34-meter antennas. These facilities can combine their capabilities to detect signals that are thousands of times weaker than a standard FM radio signal. The Deep Space Network allocates several hours each day to monitor these faint signals from Voyager 1 and has consistently demonstrated its responsiveness over the past 5 decades. Our methods for detecting these signals have seen significant advancements. Consequently, there is no practical limit to how far we can extend our reach in communicating with distant space explorers. So, how far can Voyager 1 truly journey into the depths of space? The answer lies in the ever-expanding gulf that separates it from our home planet. With every passing day, Voyager 1 is further away, a celestial messenger on an endless odyssey. However, sending and receiving signals becomes increasingly challenging as Voyager 1 ventures farther from Earth. The data rate slows down, making it progressively more difficult for us to communicate with this intrepid traveler. Despite these challenges, Voyager's journey has no theoretical limit to how far we may extend communication. However, in practice, our ability to communicate with this incredible spacecraft has an expiration date that is only a few years away. Voyager 1's limited energy reserves limit its ability to collect scientific data. One of its primary instruments, the cosmic ray subsystem, is collecting data on cosmic rays, but its mission will eventually terminate as the spacecraft's power source dwindles. Voyager 1's power is generated by 3 radioisotope thermoelectric generators, RTGs, that convert heat from plutonium-238 decay into electricity. However, as plutonium-238 decays, the RTG's power output decreases and eventually becomes insufficient to meet the spacecraft's power requirements. The power rate due to exponential decay of Voyager 1's energy reserves will deplete faster in its final years. To conserve power, the spacecraft will shut down non-essential systems and prioritize communication and critical scientific instruments. In 2025, Voyager 1 will celebrate its 50th anniversary, a milestone few spacecraft have achieved. Voyager is nearing the end of its mission, which has shaped our understanding of the universe and inspired generations of scientists and dreamers. As we say goodbye to this intrepid explorer, we celebrate its indomitable spirit, enduring legacy, and timeless message to the stars. Voyager 1, while being a little spacecraft, has had a significant impact on humanity. It has not only enlarged our horizons, but also aroused curiosity, imagination, and a sense of wonder. Voyager 1 represents our place in the universe as a pale blue, suspended in a sunbeam, a fragile oasis in the cosmic ocean. As it sails into the unknown, it carries the hopes, dreams, and aspirations of all humanity, a testament to the boundless spirit of exploration that defines us as a species. As we contemplate the future of Voyager 1 and its eventual journey into the void, the legacy of Voyager 1 is a testament to the spirit of exploration that transcends space and time. It is a story of courage, curiosity, and the unwavering pursuit of knowledge. Even if Voyager 1 goes silent, its message will live on, Voyager 1's mission has not only expanded our understanding of the outer solar system and interstellar space but also pushed the boundaries of human achievement in space exploration. Launched alongside its twin, Voyager 2, in 1977, both spacecraft embarked on a grand tour of the outer planets, Jupiter, Saturn, Uranus, and Neptune. These missions provided unprecedented close-up images and scientific data that revolutionized our knowledge of these distant worlds. Among its notable achievements, Voyager 1 captured stunning images of Jupiter's Great Red Spot, a massive storm system larger than Earth, and revealed complex cloud formations and atmospheric dynamics. At Saturn, Voyager 1's observations of the planet's rings and moons, including the discovery of active volcanoes on Io and icy geysers on Enceladus, challenged existing scientific theories and ignited new inquiries into planetary geology and astrobiology. Beyond the planets, Voyager 1's entry into interstellar space in 2012 marked a historic milestone. It became the first human-made object to venture beyond the influence of our sun's solar wind and into the vast expanse of the Milky Way galaxy. This achievement allowed scientists to study the boundary where our solar system ends and interstellar space begins, providing insights into the dynamics of cosmic rays and the magnetic fields that shape our galactic neighborhood. The longevity of Voyager 1 is a testament to human ingenuity and engineering prowess. Designed to operate for 5 years, the spacecraft has exceeded its mission lifespan by decades, continuing to send valuable data back to Earth despite the challenges of deep space travel. Its durability in the harsh conditions of space, including extreme temperatures and cosmic radiation, showcases the resilience of its design and the dedication of the teams that have supported its mission over the years. In addition to its scientific instruments, Voyager 1 carries a symbolic message from humanity to potential extraterrestrial civilizations, the Golden Record, containing a curated selection of sounds and images representing Earth's biodiversity, cultures, and achievements. It serves as a time capsule of human existence, intended as a greeting and an invitation to communicate with us. The Golden Record embodies our curiosity and desire to connect with the broader universe. Looking ahead, Voyager 1's remaining years will be focused on maximizing its scientific output while conserving its limited power reserves. NASA continues to monitor the spacecraft's health and performance, ensuring that it remains operational for as long as possible. Each transmission from Voyager 1 provides new opportunities for discovery and reinforces its status as a pioneering ambassador of humanity's quest for knowledge and exploration. As Voyager 1 continues its solitary journey through the cosmos, its legacy will endure as a symbol of human achievement and curiosity. Future generations will look back on its mission with awe and gratitude, recognizing its profound impact on our understanding of the universe and our place within it. Voyager 1's story reminds us of the boundless potential of scientific exploration and the enduring spirit of discovery that drives us to explore the unknown.